Hello, everyone. Welcome to today's webinar on Kotlin Multiplatform, hosted by OrangeLoops. We are thrilled to have you join us today as we dive into the world of cross-platform app development using Kotlin. For those unfamiliar with OrangeLoops, we are a software development company specializing in creating high-performance applications across various industries. With that being said, Lucia, you have the floor.
Hello, everyone. Good morning. Okay. Today, we are going to explore a very exciting topic in mobile app development that is Kotlin Multiplatform. As you know, the world of mobile app development is constantly evolving. One of the biggest challenges nowadays is facing and managing how to share code between different platforms. Android and iOS are very different topics and kind of users, so sharing code between them is one of the biggest challenges nowadays. In this talk, we will dive into how Kotlin Multiplatform helps solving these problems by enabling us to share business logic and UI components between Android and iOS. We'll also discuss Compose Multiplatform. That is a JetBrains UI framework for building cross-platform user interfaces. Okay, so let's start with a brief introduction to Kotlin Platform. This technology allows us to write shared code across platforms. This reduces duplication and maintenance efforts. Traditionally, we would write separate code bases for Android and iOS, but with this new tool, Kotlin Multiplatform, you can share common logic between the two, iOS and Android, leaving only platform-specific code for UI and system interactions. The most common use case for Kotlin Multiplatform is mobile development, where we can share code between Android and iOS apps, but it is also useful for web and desktop applications. The architecture is really very simple. It has a client multi-platform for Android, iOS, desktop, and web, where you can write the UI and platform-specific code for each of the structures. And then you have the common multi-platform. This is where you write the shared business code between the different architectures. Where is Compose Multiplatform? Okay, so Kotlin Multiplatform, as we said, is useful for sharing business code and leaves the UI for each of the platforms. Compose Multiplatform is going a step further. Compose is a declarative UI framework that simplifies the process of building user interfaces. It was originally developed for Android, and it was called Jetpack Compose. And it has now been expanded to work on other platforms, including iOS, desktop, and web. The iOS support is in beta, so it's really recent. This allows developers to write a single code base for UIs that work across platforms. So Compose Multiplatform provides a seamless experience by leveraging Kotlin's expressive syntax and declarative approach to UI development. With Compose, you can create UIs, use functions that describe the interface in a readable and maintainable way. And this not only reduces the amount of code, but also makes it easier to reuse components. It's seamlessly integrated across different platforms. And whether you are targeting Windows, macOS, Linux, or iOS, and Android, developers can leverage the same core UI components and principle, and the UI looks the same in every platform. So you have a consistent code and a consistent app in all platforms. Okay. Okay, to make a proof of concept and test these new technologies, we decided to replicate the harvest application. We wanted to test the capabilities of Kotlin Multiplatform and also Compose Multiplatform. So we created the clone of the harvest time tracking app. This application basically solves time entry management. Users can create, delete, and edit time entries. This allows us to dive into date handling. The idea is to make an efficient date selection and management that allows users to pick dates. And also we explore the navigation of Jetpack Compose. This is a smooth navigation between the sections of the app, and really easy to use. This project allows us to fully test both technologies, Compose Multiplatform and also Kotlin Multiplatforms, and understand their strengths and their limitations. Okay, so in our first approach, we used only Kotlin Multiplatform to share the business logic between the platforms, while the UIs were written separately for each platform. For Android, we used Jetpack Compose, and for iOS, we used Swift UI. Both frameworks offer a declarative approach to UI development, but we still had to write the UI code twice, one for each platform. We also implemented the model view model architecture, which is a popular pattern for separating concerns in mobile applications. One of the challenges we encountered was managing states and consuming those states from iOS, such as dates or strings and lists between the platforms. So here we have two pictures of the application we developed. This is iOS dark mode. We are going to show a demo in a few minutes. We'll go on. Okay, let's dive deeper into the architecture of the project. We use the model view model pattern, and to make it compatible with Kotlin Multiplatform, we replaced all the Android's standard view model libraries with a new library that is written specifically for Kotlin Multiplatform, that is called Observable View Model. It is published in GitHub and is very well documented. So it's very straightforward to make the change between Android's library and this one. Mostly what we have to do is to add these annotations that we can see here. Annotations, native coroutines and native coroutine states must be added to all the state we want to share. And this allows us to, from iOS, consume the state and update the state without any trouble. And we look into a lot of types of states with strings and numbers and lists of strings and numbers. It was very straightforward to declare the state and consume and change it from both iOS and Android. But then for more complex types like dates, it wasn't that straightforward. When working with Android and iOS, we have a problem because Android supports Java libraries for handling dates, but iOS does not. This forces us to use a library developed by Kotlin that is called Kotlin Datetime. This allows us to handle date-related functionalities in a platform-agnostic way. And also we had to write specific functions to change from a date from Kotlin to a date in iOS. These functions allow us to change between a date from Kotlin to a date of iOS. Okay. There are other functionalities of Kotlin Multiplatform that we did not test in our Harvest clone, but they're very, very great. One of them is serialization. Kotlin has a library that is called Kotlin X serialization that allows us to make a conversion between a JSON and a class that we define. And Kotlin Multiplatform also provides support for the known library Ktor that enables developers to perform HTTP requests and manage responses effortlessly in a platform-independent way. So Kotlin Multiplatform allows you to make requests from your shared code, handle the responses, for example, with serialization, and then pass this result to your UI in Android and Swift. Well, in this point, we draw some partial conclusions, only having the first part of the proof of concept. Most of the information to get started with Kotlin Multiplatform is well documented in their official webpage. You have a wizard that allows you to create a template project with the basics of Kotlin Multiplatform, and a lot of tutorials on how to go on and make your first application. But there's still a lack of resources for more complex topics. When you try to develop a more complex application, there are some information that is still not available from the official source. But also it's clear that the advantage of sharing code that otherwise would be duplicated in iOS and Android are very great. This allows you to reduce the time spent coding because all the business code is written only once. You don't have to replicate it in both platforms. And the main drawback is that we still had to write the UI code twice. So we reduced some time in the business logic, but we still had to write some code twice and to make it look similar twice. So then we ended the first approach and we went further and tried to integrate Compose Multiplatform. As I said before, Compose Multiplatform is an extension of Jetpack Compose. There's a UI library. Okay, this made us reuse most of the code. For the Android application, we used in the first approach Jetpack Compose. So when we went further and tried to use Compose Multiplatform, we reused most of the code that we already have. While most of the code was easily reusable, we did run into some issues. For instance, some certain UI components, like the date picker, have some problem in iOS. The thing is that iOS does not support Java time libraries, so we have to rewrite and use Kotlin X datetime. Also, we had to adjust some UI problems with iOS that we will discuss further. And for this application, we also use the model view model pattern, but we use the library that is from Android, from native Android, and not the Compose Multiplatform one. Here we have two images of the final approach in iOS. We can see some difference between them and the iOS approach. There are some components and things that had to be done manually, while in Swift UI, there are some components that are already built for us, but there's no easy way to translate them to Compose. So they had to be done manually. So we will look into the steps we had to take to migrate Android UI to Compose Multiplatform. As I said, most of the code could be migrated without effort, but there were some adjustments that had to be made. For instance, Harvest application has a calendar icon. This icon is available in an extension of material icons for Android, but Compose Multiplatform only has the standard material icons. So you have a wide variety of icons to choose from, but you don't have all of them. So for example, the calendar icon was not available in Compose Multiplatform. So we had to take it off or choose another one. Our problem we have was managing dates. For the first approach, we have a date picker in Swift UI and a date picker in Jetpack Compose that manage all the dates, and then we just send the data to the business logic. But here we had to implement the UI in iOS and Android altogether. So we have to use a library that could support both. Java was not an option. Java is not allowed in Compose Multiplatform. So we have to start using the specific library for Kotlin that is called Datetime. Datetime is a new library, especially compared with Java utiltime. And there are some features that are in Java utiltime that are not available in Kotlin X Datetime. So it's a great library, but there are still some functionalities that have to be done. We couldn't convert all the code, but we managed to make a date picker working in both Android and iOS. Then we have the problem with iOS structure or layout of the screen. In iOS, there are some borders of the screen that are kind of reserved. Only you can change it from Swift UI, and Compose Multiplatform doesn't have access to all the screen. So when you change the screen color, there are some white borders still. So we have to find a workaround to this and to make Compose Multiplatform available to change all the screen color. So that was a setback. And also we have to change the view model library. As I said earlier, we had in the Compose Multiplatform, we had to use a specific library for the view model that was written especially for Compose Multiplatform. But here, this doesn't apply. We had to go back to the Android native view model. In a way, this was good because there's a lot of information about the view model library from Android because it has a lot of support. And then we draw partial conclusions of this second approach in itself. Most of the code from Jetpack Compose can be used in Compose Multiplatform without much effort. We still had to change some things, but most of the code was the same. The date picker was the one that had to be done from zero. The iOS support for Compose Multiplatform is in beta, and they are all the time making new components for Compose Multiplatform. The day picker was one of the recent ones. It has a support now for iOS, but the main thing about Compose Multiplatform is that everything looks the same in iOS and in Android. So the day picker as well looks like a component from Android and not the component from Swift from iOS that we all know. So it looks a little bit like Android still. Other conclusion that we draw is that some Compose libraries do not have support in their multi-platform versions. So there's a chance that the code you write in Jetpack Compose cannot be entirely translated to Compose Multiplatform. And even maybe there are features that cannot be developed in Compose Multiplatform nowadays. Of course, some of the native UI features from iOS are lost because we try to make everything look the same and we save some time, but the essentials of iOS are kind of lost. Okay, so we also draw some general conclusions comparing both of the approaches. For the UI, in Kotlin Multiplatform, we have a pro that is you can keep the UI and the user experience for both Android and iOS users. They are used to different kind of UI. So with Kotlin Multiplatform, you can still maintain that. The thing that is not so good is that the UL still must be done twice as before. A very good thing is that the logic is all centralized, so you code and test your business logic only once. That is good for a lot of reasons. You code only once, so you reduce the time spent coding. The tests are only built once and for one code. When you change something, you have to change it only once. And it allows you to be consistent in both applications, iOS and Android, because the logic is the same, exactly the same. About resources, as I said, it allows you to reduce hours of coding and testing, since you have to do half of the work. But you still need Swift and Kotlin developers. Kotlin is used for the logic and also the Android application, but you still have to have Swift developers to develop the UI for iOS. About the documentation of Kotlin Multiplatform, there are almost 4 years of experience and material, so it's enough to get started. But more complex information is still in a lack, because we don't have a lot of information of complex applications being built with Kotlin Multiplatform. So there's a lot of information that is needed that is not available, neither in the official webpage nor in other pages of people using it. So people are trying to adopt it. It has a lot of support from Google, but there's still a lot to do in Kotlin Multiplatform. And about Compose Multiplatform, for the UI, we have that not only the business logic is written only once, but also the UI. So you reduce hours also here. But the main drawback, as we said, is that iOS doesn't feel native. The components still look a little bit like Android. So in iOS, you think that you are running a an Android application and not an iOS one. Then we also have centralized logic. You call and test your business logic only once, like in Kotlin Multiplatform. And about the resources, allows to reduce hours of coding and testing, but also there's no need for the Swift UI developers. So everything is written in Kotlin and Compose. And the cons are that although no Swift code is written, you still need a macOS device to build the iOS code and use the iOS simulator. This is really important because nowadays to develop for iOS, you have to have a macOS device. And this is something that you still have to have. I mean, you can't use Compose Multiplatform in iOS unless you have a macOS device. And about the documentation, Compose Multiplatform, support from Google, has a lot of support from Google. Content and documentation is being generated, but is newer than Kotlin Multiplatform, so it has less documentation. And then the information about iOS support is limited. The iOS support is still in beta, so it has a lot of features to be developed, a lot of bugs that may be present in your application. So there are still some issues about that. Now I want to share a demo of both application in iOS, one in Kotlin Multiplatform and the other one in Compose Multiplatform. The idea is for you to look at them both, and you're going to see clearly the differences between both UIs. And I have it here. Okay. Sure. Okay, this is the Swift UI approach. Here you can, if you know Harvest App, is kind of similar to the one we know. You have the calendar, all the weeks, you can ask for more. Then you can track your time. We have the projects, the tasks, we can also have the date. The date use the native date picker from iOS. And we can also track how many time was spent, and then like write a note or something that is optional, and you can save the time entry. The time entry will be saved in the day you make. Then you have the total count of the week or of the day, and you also can edit the time entry and also delete it. Okay, the idea of this application was try to replicate all the features that has the Harvest application and make it look like it is in iOS. I think it was kind of similar. Now we are going to see the one in Compose. Okay, so this one is from Compose. I think that you can see some difference from the beginning. For instance, the calendar icon is not there. We don't have something like this in Compose Multiplatform. The functionality of the dates, it's exactly the same. We reuse the code. And also we can see that some of the code is different. Here we have the date picker. As I said, this is an iOS application, but the date picker looks a lot like a date picker from Android, although we are in an iOS application. So this can feel a little weird for iOS users that are used to some of the code. This trash icon is also an icon problem. The minus icon is not available in Compose Multiplatform, so we have to choose another one. There you can edit and also delete tasks. So the main thing about this is that functionality is not lost. In both of the approaches, we can do the same, but visually speaking, they are different. They have different components. One of them are from SwiftUI, the other for Compose, and they look different. And okay, so here we can see what I said about the difference in the user experience of iOS. Nowadays, I think that Kotlin Multiplatform is a really good tool, but Compose Multiplatform has a lot of work to do before it can be applied to iOS users. So there is a good approach, it's a good way of thinking, but there's still a lot of work to do. Okay, and that's all for now. I don't know if you have any questions, you can ask. I'll be happy to answer.
One question I have for you. So I know there's some limitations about the component for iOS, but how about the native gestures, like swiping left or right to go back or forward in an app? Would Kotlin have limitations of that?
Yes. Nowadays, the navigation of Compose is done with a form of Jetpack Compose, but it doesn't have support for iOS gestures yet. I think it's being developed, but nowadays it doesn't have the support of the iOS gestures that SwiftUI has.
Nice, thank you.
I have a couple. My background's in business finance, so of course I have a few business related questions. Sort of first one is like, what are the key advantages for a business and companies adopting Kotlin Multiplatform over traditional native development?
Kotlin Multiplatform allows business to share a significant portion of their code base between platforms like iOS and Android, and that obviously reduces the duplication and the development overhead. This translates to faster development cycles, lower maintenance costs, and a more consistent product across platforms. By focusing on shared business logic, companies can ensure that core functionalities behave the same on both platforms, while still delivering a native experience for users. So I think that it has a lot of advantages. It reduces costs, it reduces time spent coding, and it also ensures a better product.
Okay, cool. For companies that are sort of hesitant to switch, what would you say are the most compelling reasons to consider Kotlin Multiplatform?
I think that the most compelling reason is the ability to reduce time and costs. It improves code consistency, simplify the maintenance. You have a code that is very big, it has been developed for years. It's good to have all the code in one place. You have to change things only once, and when you change one thing, it's changed in both applications. You don't have to replicate that and expect to behave the same way. And also Kotlin is fully interoperable with existing native code. So companies don't have to fully rewrite their apps. They can start gradually changing their apps with Kotlin Multiplatform modules, and that reduces costs and also allows them to go slow and change the code like a little bit.
Awesome, cool. And that sort of leads into my final one, which is how does Kotlin Multiplatform address long-term scalability and the overall maintainability, which of course is really important for a business investment?
I think that Kotlin Multiplatform promotes long-term scalability by allowing teams to evolve and maintain a single code base for business logic. So that simplifies updates, feature additions, and also I think that reduces a little bit the technical debt that often comes with maintaining separate code bases for Android and iOS. Maybe you spot some changes that had to be done to the logic and you do it in one, for example, for Android, and then the iOS is left behind, and then you start to have difference between your codes, and then they start to behave differently, and it's really difficult to see and to spot where that is happening. And with Kotlin Multiplatform, you avoid all those problems. You have the code in one place, and you have to change it only one. I think that over time, this can lead to fewer bugs. It's easier to update and to scale. I think that by centralizing logic, business can focus more on user experience and less on platform-specific issues.
Awesome. Thank you. Awesome. Thank you guys very much for joining.